One of the first 3D designs I posted online a couple of years ago is also the most popular design I've posted so far. It's my tool holders with embedded magnets. It was also one of the first YouTube videos I posted. There were three different sizes in that post, and I've had a few requests for more sizes, and indeed I've found such a need myself. Rather than posting more variants and sizes, I set out to generate a parametric design that enables you and I to generate almost any size and configuration desired. I wanted optional embedded magnets and optional screw holes. Here you can see how fast and easy it is to reconfigure the tool in Fusion. You can also make these changes directly in Bambu Studio. Keep watching the video and I'll show you the details. These organizers have really worked out well for me, but in the 2 years I've used them, I learned that there were some changes that could make them even better. That's what this video about. In it, I'll show you the following. First, I will show you a couple of not so obvious reasons to be able to make many different sizes and to modify the design itself. Next, I will show you why I chose Fusion for this type of design. Then I will go over every user parameter in Fusion and how you could handle them very efficiently. As I mentioned, you can change the parameters directly in Bambu Studio, and in the next segment, I will show you how to do their stat. Following that, I will show you how to print the magnets directly into the tool. No glue is necessary. In the final segment, I will show you how to handle logical parameters in Fusion, just in case you want to make similar flexible designs yourself. I have marked each segment in the description so you can skip parts that do not interest you. So, other than the obvious reasons for different sizes of the tool holders, what was it that I learned from using the organizers in my toolbox that necessitated some other options? The rare earth magnets I used in the toolbox holders are very strong, but unless your drawer bottom is made of a magnetically responsive material, they won't work. Obviously, wood or plastic would not work, but even some steels like stainless steels or very thin steel bottoms also tend to have very low or no holding power for the magnets. My toolbox is made of stainless steel, but the bottoms are carbon steel. The problem is they're very thin. Therefore, when slamming the drawer, the organizer row gets misaligned. Additionally, for items like stubby screwdrivers with a lot of mass and little steel, they tend to slip out of the tool holder, so a tighter fit is necessary. The simple solution to this movement is 3 or 4 screws in the tool holder row. And if you print each item snug enough and specific to each tool, you might even skip the magnets altogether. I use the tool organizers for other items such as chisels, where I would like a taller tool holder. Therefore, my new design allows size changes in all directions. That brings me to the reason why I switched to Fusion for my designs. My original tool holder design was made in SketchUp. Not knowing better at the time, I was quite pleased that I could split the tool holders into smaller segments so I could make size changes without having to redraw everything. But this is no match for parametric design. The ability to set measurements and options and be able to change those things with a click and a simple input is far superior to editing the basic drawing. Let's go over all those size and options parameters in Fusion and how to handle all those adjustments quickly and explain each and every parameter that you can change. Open the tool holder file and then close the Fusion browser. Now use your mouse scroll wheel to reduce the size of the tool holder and press and hold the scroll wheel and move the image to the side to give us room. Now open the parameter window and resize the columns and the size of the window. We need to be able to see all the starred favorite parameters and all the columns, especially the expression and the comment column. Once you have sized the window and the columns, click on the comment header to sort by this column. Unfortunately, Fusion does not allow you to set an automatic sort, so you will need to do this manually every time you open this. I tried to make the comment simple and easy to understand, and once sorted, you'll see all the option switches on top and all the sizing parameters below that. As you can see here, Fusion does keep your sizing in the session, but again, the sort order is not preserved. The first option switch in the list is the screw hole. If it's set to 1, you'll get the hole, and if it's set to 0, it disappears. Obviously, we do not want the screw hole if we're planning a center magnet. So if that switch is set to 1, the screw hole will also disappear. This is controlled by Boolean logic, which is widely used in computer programming, and it can be very sophisticated. It isn't in Fusion. In Boolean logic, 1 equals true, whereas 0 equals false. In Fusion, it's merely 0 false, and any other value is true. So you can set any other value than 0 and it will hold true. For the next 2 switches, I will turn off the screw hole and I will use the section view to show you the effects, which can be observed absent any further comments from me. The last switch is to remove the male snap piece in case the tool holder is placed at the end of the row. The rest of the parameters are for sizing. First, the magnets. Input the exact measurements of your magnets. The tolerance parameter provides enough clearance to insert the magnets. The tolerance numbers pertain only to the magnets and to the snap connectors. For all other dimensions, if you experience plastic shrinkage, you will have to adjust your inputs. Now just take a look at the changes in the design as I make parameter inputs. The comment column should also provide enough information for you as you prepare your tool holders. Now let's look at how you apply these parameters with Bambu Studio. To be clear, and before you make a bunch of comments, I use the term Bambu Studio loosely. It's actually in Bambu's MakerWorld webpage you make the parameter modifications. You can access MakerWorld from inside Bambu Studio by going to the home page and clicking on the MakerWorld icon. From here you can search and open the designs and as you would on the web page. You can go straight to the web page for this design by using the link in the video description. I will use the web page here. What you do is click on the green Customize button. That will bring up this page where you see all the stored favorite parameters from my Fusion file. Since I just showed you what each parameter does, I'm not going to repeat that here. I will merely set a few of them here and I will generate the resulting tool holder for downloading. Be advised that this is being played back at double speed. The generator takes a little time. Once the item is generated, click download and just follow the prompts. You now have a new customized tool holder ready to print. If you are a designer yourself, please consider sharing your projects with all of us, and please upload them with parameters. I previously uploaded a video showing you how to do just that. There's a link in the description to that video. Now let's take a look at how you insert the magnets in your print. I had that in the original video, so I'm just going to repeat that right here. The last part of this video is for Fusion users. I'm going to go on the assumption that you already know the basics of Fusion, so I'm strictly covering how to use the option switches that utilize Boolean logic. The logic statement is a simple if-then statement. It is structured in this manner. The word if, beginning parenthesis, your formula, semicolon, the result if true, semicolon, the result if false, and the end of parentheses. It's that simple. So how do you apply them in Fusion? You saw my switches, which are simple, no unit parameters that result in true or false as 1 or 0. I will start with the switch I use for the snap connector. I made an expression called calc and snap. Let's look at the formula and where it's applied. It is applied in the very first sketch. Let's move the tool holder a little bit so we can see the sketch a little easier. Let's click on Edit the Sketch, and right here where I sketched the male snap part, I use the expression calc and snap. If that statement is true, the snap is sized by the parameter snap depth minus the tolerance to make it fit. If it's false, it's set to 1/10,000th of a millimeter. Why? Well, because if I set it to 0, the Fusion formula would actually fail and the drawing won't work. But since your 3D printer will not be able to detect a 10,000th of a millimeter, this does work. I used a similar trick for the magnets, but instead of handling this in the drawing, I just went to the extrusion and put the formula in there. And here's the formula. As you can see, it's pretty much the same format as the snap connector. The center magnet has its own switch, and since the magnet holds a copies of each other, I was actually able to use 0 for the center magnet. The last switch that controlled the screw hole had me stumped. I kept getting errors. This one involved nested if-then statements. which is not complex, since I needed it off when the switch is off and additionally when the center mag is on. This was not the stumbling block, however. Notice how I used two 10,000 millimeter for the result when the switch is off and not one 10,000. Look what happened in Fusion if I set it to the lower value and I turn the switch off. It took me a while to figure this out, but then I realized when making a screw in the hole feature, Fusion expects the head of the screw to be wider than the thread, thus the error. I have used logic in several Fusion designs. Just look at my phone cup holders. The charging ports appear automatically when the phone design is sideways. I hope this video has inspired you to improve your own designs and that you'll share those designs with the rest of us. For now, thanks for watching. See you next time.